Alright, here's your study guide for exponential characteristics. So I started with f of x equals 4 to the x power. I make my table. I have -2 and 1/16, -1 and 1/4, 0, 1 and 1/4 and 2/16. So I created my table. Graph and label the function. So we're going to look at our graph here. I'll label my asymptote. I drew a dashed line for my asymptote here. You see the gray. I did my y-axis going up by 2 and my x-axis going up and down by 1. I put my function, put my infinities for my x and my y's. Also right here I put my points. Notice that my line will never cross 0. My y-intercept here, you can see it's crossing at 1 and it's increasing. Alright, so my domain here was from -infinity to +infinity. As we look at our graph, we got from -infinity from the left to +infinity to the right. It goes on forever to the left and forever to the right. You could also call this all reals. And we can use this symbol right here for it. My range is from 0 to +infinity. If we look, my lowest y value is y equals 0. And it goes up to +infinity. Alright, we look at if it's increasing or decreasing. It is increasing from -infinity to +infinity. Remember, increasing deals with intervals and only x values. So it is increasing. As you know, you can see my graph is going up from left to right. So it's going up from left to right. Alright. There's no maximum. There's no maximum. As you can tell, it keeps going. That's not a maximum number to infinity. And my minimum is y equals 0, or 0 for our y. Alright. In behavior, as x approaches -infinity, y approaches the asymptote y equals 0. So we look here as x is approaching -infinity, so as x is going left, y is approaching 0. Alright, remember, while x is decreasing, what is y doing? And as x is approaching +infinity, so x is going this way, my y value is going towards +infinity. Alright, now my y-intercept is equal to 1. We can see that from our table. We can also see it on our graph right here, y equals 1. Well, let's write that 0, 1, not y equals 1. Alright, x-intercept, there's not an x-intercept. Notice that it does not ever pass the x-axis, so therefore there is not an x-intercept. Alright, there's no zeros because zeros are the same thing as x-intercepts. And we know that it does not pass the x-axis. Our asymptote is y equals 0. We can see that from our equation because there's nothing out here. We know that our function is y equals a b x minus h for our exponent plus k. And we know there's nothing out there for k, so that means it's 0. Alright, my next one. We got f of x equals 1 over 4 raised to the x power. We talked about this. This is going to be a exponential decay. It's going to be decreasing. So I plugged them in my function, or you can do it in your calculator. We get -2/16, -1 4 0 1 1 and 1/4, 2 and 1/16. I graph my function here. Notice it is decreasing, going down. I have labeled my x and y axis. I have my infinities. I have my asymptote labeled. I have my X and Y axis labeled here. Oh, I forgot to label this. Alright. Now, so my domain is our X value, so it's going from negative infinity to positive infinity. Would be my domain. My range would still be from Y equals 0 to positive infinity. So it's going from 0 to positive infinity because it never crosses 0 again. Alright, my graph is decreasing from negative infinity to positive infinity. We can write that all real numbers. It has no maximum. Oh, my bad, wrong one. Alright, has no maximum and has a minimum of Y equals 0 because that is my asymptote. Alright, in behavior, as X is approaching negative infinity, my Y value is going to positive infinity. X is going left, my Y is going up to positive infinity. As X is approaching positive infinity, my Y value is going to 0. The asymptote Y equals 0 here. Alright. Okay. And you see that right there. My y-intercept here is going to be 0, 1. Alright, there's no x-intercept because we have an asymptote of 0, so it's never going to cross the x-axis. There are no zeros because those are x-intercepts. And my asymptote is y equals 0, and that is how you write the asymptote equation. Alright, my next one. I have a linear equation here. So I got f of x equals negative 3x minus 2, and I made more points for this because we're going to need more because the slope is closer together or the rate of change. So I got negative 4, 10, negative 3, 7, negative 2, 4, negative 1, 1, 0, negative 2, 1, negative 5, and 2, negative 8. Alright, our domain for this function would be negative infinity to positive infinity, and our range would also be negative infinity to positive infinity. So negative infinity to positive infinity is our domain. Alright. Alright. And then our range is also going to be negative infinity to positive infinity. Lowest y to highest y, smallest x to largest x value. Alright. It is a decreasing. So we look here, we know our line is decreasing from negative infinity to positive infinity. Alright, there's no maximum, no minimum, because it keeps going on forever up and it keeps going forever down, so therefore there's going to be no maximum or no minimum. It never stops. It goes to infinity both ways. Alright, in behavior, as x is approaching negative infinity, so as x is going to the left, my y value is going towards positive infinity. As x is going to the right or going up, it's going to negative infinity. So in behavior here, as x is going to negative infinity, y is going to positive infinity. As x is going to positive infinity, y is going to negative infinity. My y-intercept here is 0, negative 2. We can get that from our table. We can also see it on our graph here. Alright. Our x-intercept we're here. I'm going to plug in 0 for my y value right over here. And I'm going to add add 2 to both sides, and I'll get 0 plus 2 is 2. Divide by negative 3, and I get negative 2/3. X equals negative 2/3, so my x-intercept is negative 2/3 and 0. And I know that zeros are my x-intercept, so it's the same thing as my x-intercept on this one. Alright, number 7. Determine if the graph table or algebraic expression represents an even, odd, or neither function. This one would be neither. It's neither odd or even because it's not reflexive over the y-axis or not rotational about the origin. Number 8 8 is an odd function because the x's and the y's are both opposite. So we got 1 for x, -1. 1 for y, -1 for y. We got 2, -2, 8, -8. So everything is just opposite of one another. Alright, in the bottom, x minus 7. Well, I'm going to use our function rule here. You can also put in the calculator and look at the order pairs. But if I make my x's negative, notice right here that my x's are opposite, but my -7 stay the same. So in order to be odd, they have to both be opposite. In order to be even, they have to be the same function. So it is neither the same or opposite. So therefore, it's not even or odd. So it's neither. So even function, notice if I make x a negative, it should come out to the same exact function as you started with. And odd, if I make x negative, the whole function must be negative or the opposite, not necessarily negative. Alright, well, good luck on your test tomorrow.